Arun Kumar Singh. I'm going to talk about radiation patterns of an antenna. The learning objectives of this sessions are that at the end of this session you will be able to describe the radiation pattern. You would be able to identify various types of radiation pattern of the antennas. So starting with the radiation pattern, it is a graphical representation of radiation properties which includes radiation intensity, field strength, phase or polarization. So basically you can say that radiation pattern represents the properties of an antenna in space coordinates. So your radiation pattern can be plotted in two types. One is known as power pattern, another is field pattern. So power pattern is a pattern, or you can say is a graph of received power at a particular distance from the antenna, and if you plot the constant radius, it will be the amplitude at that particular radius in the antenna. Field pattern represents the spatial variation of electric and magnetic field along that constant radius. So both patterns can be plotted on a linear scale. However, power pattern can also be plotted on logarithmic scale. And one important thing is that both patterns are plotted after the normalization to their maximum power received or transmitted at that particular position. So in this slide you can see three patterns. First one is the field pattern in linear scale, second one is the power pattern in linear scale, and third one is the power pattern in logarithmic scale or in decibels. If you see these patterns, you will have one thing similar to all patterns, that they are having few lobes or few wings. So these wings are known as lobes, which I am going to talk about very shortly. And if you see this, all values are normalized to the maximum power, as these are in linear scale, so it is normalization is 1, and in logarithmic scale it is normalized, that's why they are showing 0. So now half power beam width shows that the position at which power is reduced to the half of the maximum power. So that position is known as half power beam width. So in the case of field pattern, if you see at this point power is going to be half, so this is the half power beam width. In this point this is the half, so it is half power, and in the logarithmic scale half power is represented by a loss of 3 dB in that power. So at these 3 dB points, this is the half power, or sometimes we call it 3 dB power beam width. Now as I told you that if you see these radiation patterns, they have few lobes or few wings. Name them as lobes, and these lobes are classified in 4 categories. The first one is the major lobe. Major lobe contains the maximum power transmitted in a particular direction. So if you see these 3 graphs, you will be able to identify which one is the major lobe. If you see here, this is the major lobe, this one is the major lobe in power pattern in linear scale, and here is the major lobe in logarithmic scale. Next to the major lobe, there are minor lobes which are having power less than the major lobe. So here this is the maximum power after the major lobe. So this is minor lobe. Similarly here in this pattern you can see this lobe is minor lobe, and in this 3D pattern this lobe is minor lobe, which is having less power than the major lobe. Next to it, we have side lobes. So there can be several side lobes in a radiation pattern. If you see this pattern here, we can see 1, 2, 3, 4, 5, 6 side lobes. So these pattern side lobes are having less power than minor lobes and major lobes. Similarly here, these patterns you can see in this picture, in this 3D, in this power pattern in decibels, you can see minor lobes. And there is one more lobe known as back lobe, which is just at the back side or opposite side of the major lobe, which contains very small power. So for example, if you are talking about a directional antenna, then there should not be any back lobe because the maximum power is transmitted in a particular direction. So there should not be any back lobe. So if you see this pattern, so now I have told you that we have four types of lobes. One is major lobes, minor lobes, side lobes and back lobe. This represents the three-dimensional view of a radiation pattern in which you can easily visualize how they look like. And now coming to the types of radiation patterns. Normally we can classify all our antennas in three categories. One is isotropic antennas, another is directional antenna, and third one is omnidirectional antenna. So this categorization is done depending upon their radiation patterns. So if your antenna is radiating power in all direction, then that type of radiation pattern is known as isotropic radiation pattern, and that particular antenna is categorized as isotropic antenna. If you see this radiation pattern, this power is equal power is radiated in all directions, but normally we don't have this type of pattern from any antenna because this is a ideal case situation which we are not going to have in real life applications. Next, coming to the directional antennas, just like horn antenna, parabolic antennas, which we normally install for receiving the signals using D2S technology. So these, our antenna which is installed at our home is directly receiving the signal from the satellite. So for that we need some directional antenna. If you don't set the direction, you are not going to receive any signal. So these directional antennas have major lobes, then side lobes and minor lobes. The next category is the omnidirectional antennas, in which your antenna is radiating equal power in a plane. If you see this picture on the right hand side, at the lower left hand side, you will see a radiation pattern which is of if you take the cross-sectional view, you will see 8 light structures. So that means that it is radiating in that axis, X and Y axis, and not in Z axis. So this type of radiation pattern is known as omnidirectional radiation pattern. So the best example to represent omnidirectional antennas is our Yagi Yoda antenna, which we used to install to receive signals of television a few years back. So having several antennas connected together, those antennas were dipole antennas, and every dipole antenna has omnidirectional properties. So that looks like this pattern, 8 pattern. So now at the end of this session, you have learned about the radiation pattern, and now you are able to identify various types of patterns. Thank you very much.